Okay, we are recording. So welcome to the Friday, April 24th engineering class. Before I start going through the normal material, does anybody have any questions about life or how the class runs, or any general questions at all? Okay, I'm not seeing anything. All right. Okay, well, let's go ahead and get into the fun stuff. Now, last time we met, we talked about the metric system and why the metric system is so much better than this stupid imperial system that America's stuck with. And I mentioned the video from Fox News where they rallied against it, they railed against it. They said that it's the yoke of tyranny, I think was the exact words. Let's take just a quick second here and let's watch this video because it is just so funny. I cannot believe that any organization that claims to be a news organization would say something that's so utterly absurd as this. But here they did. Okay, so hopefully you guys can all see this now. Okay, so this is just a little short clip that I'm going to play. That this is not a joke. Fox News actually said this on the air. It's just astounding me. Okay, so let's see. Here we go. All right, so hopefully the video lag won't be too much of a problem. So let's see what Fox News has to say about the metric system. did you did you catch the look on his face when he said kilograms? Let me back that up again. That's just too funny. Check out the look on his face when he says kilo. Oh, you can't hear it. Oh, okay. I'll go back to the very beginning. Okay, there's this thing I need to enable here. Okay, so now you should be able to hear it. Okay, so let me take it back to the very, very beginning. Let's see.
Measure their environment in millimeters.
Okay.
Almost every nation on Earth has fallen under the yoke of tyranny, the metric system. From Beijing to Buenos Aires, from Lusaka to London, the people of the world have been forced to measure their environment in millimeters and kilograms. The United States is the only major country.
So did you catch the look on his face? Let me just go back one more time. This is hilarious. This is an actual news organization. Okay, so yeah, Kylo Ren, yeah. Okay, this time I'll let it play. I won't stop it. Okay, here goes.
Almost every nation on Earth has fallen under the yoke of tyranny, the metric system. From Beijing to Buenos Aires, from Lusaka to London, the people of the world have been forced to measure their environment in millimeters and kilograms. The United States is the only major country that has resisted, but we have no reason to be ashamed for using feet and pounds. So says New Criterion editor James Panaro. We spoke with him recently.
I'm joining you tonight as an anti-metrite. I'm taking a stand against the metric system, the original system of global revolution and new world orders.
God bless you. That's exactly what it is.
I'm not going to play the whole thing. I'm going to stop it here. But I just am so astounded that a news organization, or at least a place that calls themselves a news organization, would take such an utterly absurd point of view. Just blows me away. Okay, so anyway, let's get back. Yeah, our society is doomed. It's just too funny. Okay, so let me get back to the real stuff here. Okay. All right, so here is quiz question number 1. And hang on, I got a couple of windows I got to move around here so I can see things. Okay, so I trust that you guys knew that if you want to calculate kinetic energy, the formula is 1/2 mv². And so when you put it into your calculator, the number that you get is 2,664. But the number that I put up here is 2,700. Why do you guys suppose that I rounded off like that? All right, so David is saying sig figs, which stands for significant figures. We have talked about significant figures several times, and I've given you a little brief introduction to it. I think now is a good time to take a few minutes before we go over the rest of the answers to the quiz questions. And let's talk about sig figs, which you need to understand is short for significant figures. We need to get serious about it. Okay, so if it'll let me, okay. Yeah, it's time for us to get serious about significant figures. So what I'm going to do today is I'm going to spend a fair amount of time talking about sig figs, how it works, and from today on, I'm going to start insisting that we use significant figures properly when we calculate numbers. And our quiz today is going to be about significant figures and rounding properly and that kind of stuff. So pay close attention, because what we're going to do in the next few minutes is we're going to talk about sig figs. And then once hopefully everybody is up to speed on sig figs, then we'll come back and then we'll talk about the rest of the answers to the quiz last time. Okay, so let me start off by asking a simple question. What is 3 times 6? And I'm going to pause here. Okay, wow, you were way ahead of me there. Okay, so Sky says 18. John says depends. Simon says 17.5. Okay, so how is it possible that 3 times 6 might not be 18? Okay, well, remember last time we talked about how it is that 2 plus 2 might not be 4. Okay, why is it that 2 plus 2 might not be 4? Well, the answer is that it depends on what you're talking about. If you're talking about pure numbers, if you're talking about scalars, then yeah, 2 plus 2 is going to equal 4. But sometimes, especially a lot of times for engineers, we are not dealing with pure numbers. We're not always dealing with scalars. We quite often have to deal with vectors. And so something that has a magnitude of 2, you add it to something else that also has a magnitude of 2, may not be 4 if those things you're adding are vectors. Okay, so the reason why 3 times 6 might not be 18 is not necessarily the vector problem. It's purely a sig fig problem. So tell you what, I like to think of it this way. I say, okay, here is a rectangle. And what if instead of asking you what is 3 times 6, I ask you what is the area of this rectangle? Okay, so the first thing you're going to have to do is you're going to have to measure the sides, because you know that the area of a rectangle is the height times the width, right? So you get out a ruler and you measure the sides. All right, so if we ask somebody to measure this, they put the rulers there, okay? And let's suppose that the person who did the measuring, they said that the height was 3, and they said the width was 6. Now, if you look carefully at how the rulers line up, you'll find out that the height is not exactly 3. They just rounded it off to the nearest inch. You know, it's actually a little bit less. And the width here is not exactly 6. It's a little bit more. Yeah, Danny, you're right. They aren't exactly 3 and 6. But if you round off to the nearest inch, which people like to do, then you can understand that they could call it 3. Okay, so you guys know about rounding and how rounding works. Okay, so if they followed the rules of rounding properly. Okay, so Danny is saying the person is a liar. I disagree with you, Danny. They're not lying. They're just rounding off. Okay, so if you report that the height is 3 inches, what that means is that the real true height could be anywhere between 2.5 and 3.49999. Okay, yeah, I kind of figured we were joking, Danny. Don't worry. I knew you were not serious. Okay, so you guys understand. So let's suppose that the real height is 2.6, but we want to report it with only 1 sig fig. We want to just round off the nearest inch. So if we take 2.6, we would have to round up. Now, if it was 2.4, we would have rounded down. So we know, according to rules of rounding, that if they reported the answer as 3, then the real true number is somewhere between 2.5 and 3.5. Now, the reason I said 3.49999 is because according to rules of rounding, if the number is 3.5, you would have rounded up. Okay, so that's why I say 3.4999. Okay, same thing with the width here. If they reported the number and they rounded off to the nearest inch, the actual number could have been anywhere between 5.5 and 6.5, or 6.499999. Okay, so what does that mean that the real area might actually be? Well, let's take the smallest possible number for the height and multiply it by the smallest number for the smallest possible number for the width. So that's 2.5 times 5.5. Okay, and then do the same thing for the largest possible answer here, multiplied by the largest possible answer there. And what we find is that the real true area could be anywhere between 3.75, or I'm sorry, 13, could be anywhere between 13.75 and 22.75. Okay, so if we say that the area of this triangle is 18 because we took 3 times 6, we are kidding ourselves. Okay, because if we report the answer as 18, somebody who looks at our number, they say, okay, they reported as 18. That means that they rounded it off to the nearest whole number there. So that if we report it as 18, that means that we are confident that the real answer is somewhere between 17.5 and 18.5, actually 18.4999. Okay, so we are lying if we say that 3 times 6 is 18, if we're dealing with measured numbers. Okay, we are lying to say that it's 18 because that implies that we know the answer far more accurately than we actually do know the answer. Okay, so we should not say, so if you're dealing with measured numbers, and that's the big if. I mean, if you're dealing with pure numbers, if you know that the number really is exactly 3 and then the other number really is exactly 6, then okay, fine, then 3 times 6 equals 18. But if you're dealing with measured numbers, say, we should not say that 3 times 6 is 18. So the best way to do it is to say that 3 times 6 is a number somewhere between 13.75 and 22.75. But one thing that we do that's almost as good, and that's a whole lot easier, is we say, okay, we look at how many significant figures does the one number have, and we look at how many significant figures does the other number have, and in this case, they're both just 1 sig fig. And so then we say, okay, so we should only report our answer with that, whichever one of these numbers has the least number of sig figs, that's how many sig figs we should report our answer with. So instead of saying 18, we should round that off to a number that only has 1 significant figure. So if it's 18, we're clearly going to round it up to 20 rather than rounding it down to 10. So we should report our answer as 20. Because why do we do that? Well, if we say the answer is 20, then someone looks at our number and they see we've rounded it to 1 sig fig. So they know that the real true answer could be anywhere between 15 and 25, actually 24.9999, right? So, okay, so now even that is not quite right because the real answer is actually between 13 and 22.75, okay? So but reporting the number as 20 is that, even that is not right, okay? But it's better than saying that, than reporting the answer as 18, okay? So what we're going to do from today forward is we're going to get really serious about significant figures. And so whenever we're multiplying or dividing numbers, whichever number has the least number of significant figures in it, that's how many numbers we're going to report our answer in, okay? Now, okay, so let's talk about sig figs. Well, actually, before we do that, let's do a quick question like you might see on the quiz today. So somebody type in an answer here. What is 7 times 4 if you are dealing with measured numbers? Okay, so David says 30. Everybody agrees, 7 times 4, because your calculator is going to say 28. But according to the rules that we just said, if these are measured numbers, then they only have one sig fig in them, then we should look at the number on our calculator, which says 28. We should then decide, okay, we got to either round that up to 30 or round it down to 20. So if it's 28, then clearly rounding up is the way we want to go, not down. Okay, so it looks like everybody agrees that 7 times 4 is going to be 30 if you're dealing with measured numbers. Now, if you're dealing with pure numbers, okay, then it's 28. Okay, all righty, so here's another one. Now remember last time I said you guys, I wanted you to bring calculators with you? Okay, well, I was serious. This is what we need. So I don't expect you to do this in your head. Get out your calculator, look at the number that your calculator gives you as an answer, and tell me what is the number that we should report. Okay, so Luke's calculator has died. Well, you're going to have to figure out a way to resurrect it there, Luke. Okay. Okay, so Sky is saying 162,300. Okay, well, Sky, that's the number on your calculator. But what number should we report? Okay, it looks like Dan's and Eve and David are all saying that the number that we should report is 162,000. Oh, actually, no, we're not all agreeing. So, some people are saying 162,000. Other people are saying 160,000. Very good. Okay, which one is it? Okay. All right, so Danny, don't worry. I see your comment that you're confused. Don't worry. We are going to go over this very, very slowly. Okay, so I say that the answer is 160,000. Okay, now a few of you said that it was 162,000. So it all hinges on this. Okay, the number 649. How many significant figures do you see there? Somebody type it in. How many? Just look at the number 649 only. How many? Okay, so David is saying 3 sig figs. Okay, I agree with that. Now, here's the trick. What about the number 250? How many significant figures do you see in that number? So Eve is saying 2. Let's see, does anybody second that motion? Marshall is agreeing 2. Okay, good. All right, so yes, the number 250 only has 2 significant figures. That 0 that you see right there, that 0 is what we call a placeholder. That 0 has to be there because if that 0 wasn't there, then the number would be 25. And the number 25 is very different than the number 250. Okay, so that 0 serves a very, very important purpose, but it's not considered a significant figure. And okay, so here you see 3 sig figs times 2 sig figs. Okay, so, and in a minute, I'll go through a couple examples on why 250 only has 2 sig figs. Don't worry, we will do that. Okay, but if you temporarily agree that yes, 250 only has 2 sig figs, then we've got a 3 sig fig number multiplied by a 2 sig fig number. So whichever one of those has the least number of sig figs, which is going to be the 2 sig fig number, that is what rules, that's what determines how many sig figs we put in our answer. So we look at the number on our calculator, which says 162,250. We need to round it off so it's only got 2 sig figs. So that means we either need to round it down to 160,000 or we have to round it up to 170,000. So if it's 162,000, then I hope you guys agree, clearly we need to round down, not up. Okay, the cutoff is 165,000. Okay, so anything less than 165, so we're going to round it down. Okay, so now let's talk about the zeros and why they're sig figs. And sometimes zeros are sig figs and sometimes zeros are not sig figs. Okay, so how many sig figs are in this number right here? Okay. Okay, 2 or 3. Well, there's only one answer. Okay, looks like everybody's agreeing that it's 2. And I trust that the reason you're saying that is because you recognize that both of these zeros here, they're just what we call placeholders. Okay, so I agree that there are 2 sig figs in there. Now, those of you that said that the zeros don't count as sig figs, what do you think about this number? 2,307. Okay, so Danny is saying that there's 4 sig figs now. Marshall is agreeing with him. Okay, so Danny and Marshall, I have a question for you. So in the last number that we looked at, the 8,300, we said that those zeros were not significant. But now you're claiming that the 0 is significant. What's the deal? Make up your mind. Is the 0 significant or is it not? Now, obviously, I'm just, okay. So Sky is saying that the reason that 0 is significant is because it's in between two other numbers, okay? And we know that both of those numbers are significant, okay? And so that 0 there is not there as a placeholder. That 0 really is significant. David is saying that zeros are people too. Well, sometimes they are, but sometimes they're not. Okay, so if that 0 is in between two other digits, um, those of you that are watching the recorded video, you're really missing out. There's some funny comments here. So David is saying that he's a zero rights activist. Okay, so all right, so you guys agree that if the 0 is in between two other digits that are significant, then that 0 becomes significant. Okay, so the answer is there are 4 sig figs in this number. Okay, well, how about this one? How many sig figs do you see in this number? David is saying 5. Other people are saying 3. Luke is saying 5. So Danny, I'm interested in knowing, why do you say 3? Because you're outnumbered, actually. David and Luke both say there's 5. But Danny thinks there's 3. And by the way, Danny, you are correct. Why? Why did you say 3? You can turn on your mic if you want to speak your answer. Hold down the space bar. Okay. Run for president. Okay, so
I was saying because the other zeros are placeholders. That's why.
yes, that's it exactly. The other zeros are placeholders. So before we had a number like 83,000. Okay, and so those zeros were just placeholders. These two zeros that you see right here, okay, those are placeholders, just like before the 83,000. Those two zeros are placeholders there. We need those zeros there because if we didn't, if they weren't there, we would have 0.405. Which is a very different number from 0.00405. So those zeros serve very important purposes. They are needed as placeholders, but they're only as placeholders. They're not as significant figures. So the correct answer here is there are 3 significant figures in this number, not 5. Okay. All right. Okay, one more example here. So this time we've got a 0 on the left side. We got a 0 in the middle, and I hope you guys all agree the 0 in the middle is clearly significant. And I hope you guys agree that the 0 on the left side is not significant. What about the 0 on the right? Is the 0 on the right significant or not? Okay, so I'm seeing all sorts of different answers here. It looks like people are evenly split. About half of you are saying that there's 4 sig figs, and about the other half of you are saying that there's 5 sig figs. Here's the way to think about it. Okay, this 0 over here on the right, is it a placeholder? Because think of it this way, if that 0 wasn't there, would that number really be significantly different? I mean, the 0 on the left, so the 0 on the left where I've got my arrow right now, if that 0 wasn't there, if we had 0.9 instead of 0.09, I hope you guys agree that that would be a very different number. So that 0 absolutely has to be there as a placeholder, because otherwise we would have a number that's a very, very different number. But the guy on the right, if he wasn't there, would that number really be significantly different? Okay. So if he wasn't there, we would have 0.09043. Okay, if he is there, we have 0.09043. Do you guys see that it's really the same number with or without the 0? So we didn't need that guy there as a placeholder, because that number would be the same number essentially if he wasn't there. And yet we put him there. Okay, so if we put him there when we didn't really need him as a placeholder, what that means is that we know that he's significant. Whoever it was that wrote this number, they knew that that last digit was actually a 0. Give me a sec just to read some comments here. It can't, because then naming 2 sig for single digits arbitrarily chose the digit. Okay, I'm not quite following what you're saying there, Luke, but I'm just going to move on. Okay, so the answer here is there are 5 sig figs here. That digit right there is he is very definitely significant. Okay, so here's the rule: if he's there and we didn't need him as a placeholder, but we put him there anyway, it's because we knew that he was significant. Okay, so now I hope you guys have a little bit more comfort level with how to tell how many significant figures there are in a number. So be prepared in today's quiz. There will be questions like this where I'll give you numbers. I'll say how many sig figs are in the number, and then I'll give you other where I'm multiplying or dividing numbers, and I'll say how many sig figs should we put in our answer. So remember the rule: whenever you're multiplying or dividing any two numbers, the rule is whichever of the input numbers has the least number of sig figs, that determines how many sig figs you're allowed in your output number. Okay, so Luke has just typed in something here again. Okay, yeah, I hope you don't mind, Luke, if I just move on. I don't want to get into too much little nittiness here. Okay, so everybody good with that, I hope? Okay, all right, so let's just do a real quick test question like you might see. So what is 1,293 times 2? And now assume that both of these are measured quantities, not exact quantities. Okay, so Eva's saying 3,000. You guys agree? Okay. All right, because when you put it in your calculator, you get 22,586. Okay, but one of our input numbers only has 1 sig fig. That means our answer has to only have 1 sig fig. So if we look at this left number here, we either need to round that down to 2,000 or round it up to 3,000. We're not allowed any more digits other than that. We're only allowed 1 significant figure. And we see that the number in the calculator is greater than 2,500, okay, greater than 2,500. So that means we have to round up. So the answer is 3,000. The answer is not 2,586. Well, I think that's enough. Tell you what, here's one a very important thing that sometimes people get confused about. So let's suppose that I ask you how many minutes is 392 seconds. Okay. Now, rather than make you do it, let me step you through the process. So this is a unit conversion problem. So we're going to convert this. We're going to use the Ames method to convert it, right? So the Ames method says, oops, wait a minute. I got a typo here. Okay, hang on a second here. I got to come fix a typo in here. Okay, and let me come back to this. Okay. Okay, let's try this again. Okay, so if I were to ask you how many minutes is 390 seconds? Okay, so if you use the Ames method, all right, so you're going to arrange things like I've got them here. My chat window just disappeared. Let me see if I can get the chat window back. Why does my chat window not want to come back? If you guys are typing in chat numbers, I can't see them for some strange reason. Okay, so hang on a sec, because right now I can't see the chat. I don't know why it went away. But let me finish my thought here, and then I'll figure out why the chat went away. Okay, so if you use the Ames method here, so you're going to take 390, and you're going to multiply it by 1 over 60, and you're going to cross out the units, and so you're going to get 6.5. Are any of you looking at this and saying, hey, wait a minute, the number 60 only has 1 sig fig in it? Okay, I mean, because if I were to just write the number 60, and if I didn't tell you where it came from, if I just wrote the number 60, okay, do you guys agree that if I write the number 60 without telling you where it came from, that only has 1 sig fig? So according to the rules that I just told you, I've got a 2 sig fig number, and I'm dividing it by a 1 sig fig number. So you might think then, oh, well then I've got too many sig figs in my answer here. I shouldn't report it with 2 sig figs. I should only report it with 1 sig fig. Okay. Here's the thing. This number here, that 60 that you see there, that is not a measured number. Okay. 1 minute is not measured to be approximately 60 seconds. That's a defined number. 1 minute is exactly 60 seconds. Okay. So as far as we're concerned, that 60 that you see there, that is an exact number which has infinite number of sig figs. So don't think of it as a 2 sig fig number where they're being multiplied or being divided by a 1 sig fig number. Think of it as a 2 sig fig number being divided by a number that has infinite sig figs. Okay, so now I need to pause for a second and figure out why the chat window disappeared on me. Okay, there, I think I just got it back. Hang on just a second here. Okay, so I think I got the chat window back. Except, okay, there we go. Okay, so let's see, what comments did you guys type in while I was away? Every 60 seconds in Africa, a minute passes. Okay. All right. Okay, so so is everybody okay with sig figs now? Everybody's feeling a little comfortable with it? Okay, if I don't see any complaint, okay, all right, good. Okay, all right. Now every time I click here, the chat window keeps going away. What is the wheel? Okay, hang on a sec here. I'm gonna have to play with my sharing thing here. I'm gonna turn off sharing for just a minute. Hang on. And let me see if I can get my window to come back. Okay, hold off on your comments. I see a few comments popping up here. Okay, so Zoom is being a little weird on me. Every time I go to full screen, the chat window disappears. Zoom's never done this to me before. Okay, all right, there. I think I got it back now. Okay. All right, so now, okay, so hopefully you guys are now comfortable why it is that I took my answer for question number 1 and I rounded it off. Instead of writing it as 2,664, I wrote it as 2,700. I hope we're all comfortable with that. Now that we know that, let's go on with the rest of our quiz questions. Okay, so if I want to know how much work a person does, or I'm sorry, oh my goodness, oh no, I just noticed a mistake. Do any of you guys see the mistake that I made here? This is an embarrassing mistake. Oh my goodness. Nobody emailed me to complain about it. I want you guys to look at it. Tell me, what's the mistake that I made when I wrote up the quiz here? And it wasn't a math mistake. Yeah, no, Simon, it's not a math mistake. It's a unit mistake. Oh, this is so embarrassing. How could I have done that? Joules of work. Yeah, that's crazy. Force is not measured in joules. Force is measured in newtons. So the answer that I put down here, all of these numbers here should not have been in joules. They should have been in newtons. Yeah, Danny, I agree. That's a wig. Hang on just a sec. That one's embarrassing. Let me go get the wig. I deserve it for that. Be right back. Oops, I need to put the headset on first and then the wig. Okay. Boy, I am embarrassed. Okay. I hope that you guys didn't get confused because of that. You probably did. Okay, so every one of these numbers that you see here that says joules, Okay, that should say newtons after it, not joules. Okay, because force is not measured in joules, force is measured in newtons. Energy is measured in joules, and work is measured in joules. Okay, so Dan's, you're saying 540 times something. Okay, so the way I got it is I know that, so that work is equal to force times distance, right? So if I want to know what the force is, I got force times distance, so I have to divide by d. So that means I have to take the work and divide it by 2.7. So that's how I got the answer. Okay, now let's talk about sig figs again for just a minute. If I write the number as 200, if I just write the number 200 and I don't tell you where it comes from, how many sig figs are you going to think are in that number? Somebody type something in here. If I just write the number 200, okay? So 1 to 100, I'm not sure what you mean by that, David. So give me a number, guys. If I just write the number 200 and you look at this number, how many sig figs are you going to say? Okay, good. All right, so everybody's agreeing that there's one. Okay, but we know there's actually 2 sig figs in this number because we started with a number that had 2 sig figs. We divided it by a number that has 2 sig figs, okay? And the number that appeared on our calculator was 200, but we know that there's actually 2 sig figs in that number. So how could we write it in a way so that somebody looking at that number would know that there's 2 sig figs? So David, I don't think that's going to do it. If we just write, oh, I see, 200 with a dot after it. Okay, but if we write it the way that David just suggested, which is 200 with a dot after it, that's going to imply that it has 3 sig figs, and that would be a lie. Luke, you got it exactly. Scientific notation. This is where scientific notation comes in to save the day. Okay, so if we write it as if we write it as 2.0 times 10 to the second, okay? Notice that 0 there. We didn't need that 0 as a placeholder. If we put that 0 there, that tells everybody that there are 2 sig figs, okay? So if I really want to do it right, which I do, okay, then instead of writing it as 200, I should write it as 2.0 times 10 to the second power. Now, I purposely wrote it as 200 specifically so that we could have this conversation. But going forward, you know, let's recognize that if we know that there's actually 2 sig figs in that number, let's not write it as 200. Let's write it as 2.0 times 10 to the second. Okay, so now what I'm telling you right now, guys, is something that you are going to need to know going forward at Ames and anywhere else. When you guys take chemistry, Coach Miller is going to be a stickler about sig figs. Okay, students always, they say, oh, Coach Miller wants me to do sig figs, and my response is, so do I. When you take my physics class, I'm going to be just as stickler about sig figs. Or Mrs. Zacharias, if you take her physics class, we are going to be insistent on sig figs. So learn them now, because I guarantee you are going to use them all throughout your career at Ames, and depending on what field you go into, for the rest of your life. Okay, so let's move on. All right, so question number 4. We got a car sitting at rest, okay, and then he steps on the gas, and so later the car is moving. So where did the energy come from? Well, the gasoline in the tank of his car. So that gasoline contained chemical potential energy. All right, so if we want to know how much chemical potential energy got used up, what we want to do is we need to figure out how much energy does the car have when it's moving. So when I say the word moving, that should be a clue to you to say, ah, that means kinetic, because moving means kinetic. Static means at rest, kinetic means moving. So the energy of motion is kinetic motion, that's 1/2 mv squared. We know m, we know v, so we calculate that. So that means that we had to have 614,400 joules of energy, potential energy in the gas tank, okay? And in fact, we actually had to have more than that, because I specifically said here, ignore friction and ignore other energy losses. Assume that the engine is 100% efficient at converting chemical potential energy into useful kinetic energy. And that number is wildly optimistic. Okay. Anybody know what percentage of the energy is actually converted? I mean, in a real engine, in a real automobile engine. Anybody want to make a guess as to what percent of the gasoline's potential energy actually gets converted into real kinetic energy? So Sky is saying very little, and I agree. 2.5%, well, it's not that bad. Okay, 8%. Yeah. So actually, the real answer ranges anywhere from 20% up to about 35%, depending on how efficient your car is. Okay, if you've got a small compact car that's really efficient, you might be able to get 30 to 35% efficiency. But if you got a big luxury car or a truck or something like that, you're probably only getting about 20% of the chemical potential energy converted into actual kinetic energy. The rest of it is not lost. It just gets converted into thermal energy. And thermal energy is, once the energy gets converted into thermal form, it's really hard to get it back into a useful form of energy. Electric cars are a little bit more efficient. Yes, so David, yeah, electric cars are a little bit more efficient, but even they are not perfect. Okay, so last question here. Okay, so we've got a box sitting on a ramp. Okay, so here's the ramp, here's the box sitting on it. We let go of it, the box slides down. So so when we calculate how fast that box should be moving, okay, if it was a frictionless ramp, the way we do that is we calculate how much gravitational potential energy did the box have when it was sitting up at the top. And so the way to do that is MGH, okay? And so we know that when it was sitting up at the top there, okay, that box had 2,195 joules of potential energy. Okay, so if the ramp was frictionless, then when the box got down to the bottom of the ramp, that's how much kinetic energy it should have. All of that potential energy should have gotten converted into kinetic energy, but it didn't. Okay, if we measure the speed when it gets to the bottom and we calculate what is kinetic energy when it gets to the bottom, we find out that it's only got 1,264 joules of kinetic energy. Where'd the energy go? Where'd the rest of the energy go? Well, friction turned it into heat. Okay, so if we just take the first number minus the second number, that will tell us how many joules of energy got quote unquote lost. I mean, energy is never really lost. Okay, it just gets converted into different forms. In this case, it gets converted into thermal energy. And once something gets converted into thermal energy, it's very, very difficult to get it back into a useful form of energy. And in fact, it's impossible to get it all back. If any of you go into engineering, when you get to college, you're going to take a class called thermodynamics. And thermodynamics, it deals with how to take thermal energy and convert it into useful kinetic energy. And the first thing you're going to learn is that it is impossible to take all of that thermal energy and get it into kinetic energy. It's a physical impossibility. It's one of the laws of the universe. But if you're really clever, it is possible to get some of that thermal energy back. You just can't get it all. Okay, so all right, so I'm going to ignore the comment about the Olive Garden breadsticks, and I'm just going to move us on forward here. Okay, so here is a question like what we're going to be doing next week. Okay, we're going to be talking about the efficiency of various machines. So we've already talked about the fact that a gasoline engine in your car is not very efficient at all. Somewhere between 20 and 35% efficient. Okay, this ramp that you see right here is also not 100% efficient because of the friction in the ramp. Okay, some of that energy got lost, and so here's a question that we were going to talk more about next week, but I introduce it now. I want to know what is the efficiency of the ramp. So the way to do that is to calculate what percent of the initial energy do I still have left over as useful energy after the machine has done its job. I don't want to calculate the percent of energy that was lost. I want to calculate the percentage of the energy that remains. Okay, so the way I'm going to do that is going to say, okay, so after the machine has done its job, I've got 1,254 joules of energy left in a usable format, an easily usable format, okay, which is either kinetic or potential energy. But I started off with 2,195. So what I do is I divide those, okay? Now, percentage is a common way to do things. So after I do the divided, I want to multiply it by 100. I trust that in your math class, you guys have dealt with percentages before. I'm hoping this is not the first time you've been asked to calculate the percentage. So I'm going to take how much energy I have left over, divide it by 2195. Did I write the number wrong? It's 2164. Oh my goodness, you're right. Danny, you are right. That's a typo. So yeah, it should be 2164, not 2154. Well, hey, I'm already wearing the wig. What do you want? What more do you want from me, right? Okay, so thank you for catching that mistake, Danny. Very good. Okay, so so it should be 58%, not 52 wigs. Yeah, I probably deserve 2 wigs, but sorry guys, I only have 1 wig. What can I do? Okay, so other than my silly math mistake there, I hope you guys are good with that. Okay, so now, so we finished talking about the quiz, and we've also finished about talking about the stuff that's going to be on today's quiz. But let me just talk briefly about quizzes. Some of you have recognized that I have set up Canvas in a way that Canvas allows you to retake quizzes. And I've noticed that several of you have taken advantage of that. Several of you gone in and you take the quiz and you didn't get a perfect score, so you retake the quiz. And you just keep on retaking the quiz until you get a perfect score. So good for you. I did that on purpose, okay? And I thought that everybody would recognize that, but I see that many of you did not, are not doing that. And maybe it's because you didn't recognize that it's possible to do that. So let me officially tell you right now that I have purposely set it up that way. So when you take a quiz, I want you to look at your score. If it's not a perfect score, I want you to go back and retake the quiz. And you can keep doing that until you get a perfect score. And that's not cheating. It's okay for you to do that. Okay. But there is a very important thing. Okay. After the deadline has passed, okay, then we got a little bit of a problem because what I do is I do not have Canvas set so that it automatically transfers the quiz scores into SIS or Aspire. Okay, I do that manually. So when the quiz deadline comes, I go into Canvas, I take the numbers, the quiz scores that you see from Canvas, I manually transfer those into Aspire. So if you were to come back after the deadline has passed and you were to retake a quiz after the deadline has passed, which I do allow, okay, I won't know that you've retaken the quiz unless you tell me. Okay, so it's very important that you send me an email. Now, if you retake the quiz before the deadline has passed, don't worry about it because I don't transfer the scores into quiz until the deadline has occurred. Okay, but if you were to retake the quiz after the deadline has passed, make sure you send me an email telling me that you've retaken the quiz, so that then I can go ahead and give you the higher score that you deserve. Now, there is another important thing that you need to know, is that after we take a midterm exam, I no longer allow quiz retakes after that point, because the whole idea of giving you quiz retakes is to help you learn what you need to learn so that when the midterm exam comes along, you'll get a good score on the midterm. But after the midterm exam has passed, well, then it's too late. Okay, retaking it is, it's just too late. It's not going to help you anymore. So any quizzes that we've given since the last midterm, even though the deadline may have passed for those quizzes, I'm okay with you guys going back and retaking those quizzes as long as you email me to tell me you've done so. But any quizzes that are from the previous midterm, the last midterm we had was about the CAD thing, right? So any quizzes that were before that midterm, Those guys are locked, okay? But anyone after you can do. Okay, so you had a homework assignment. Your homework assignment was to start reading chapter 3. I didn't ask you to read the entire chapter 3, but just start reading it. And then I asked you to compile a list of questions. So do any of you have questions? I trust you did the reading. Was there anything in the reading that that you found confusing? No questions so far? Okay, good. All right. Okay, so not seeing any questions, I'm just going to assume that we're good. Okay, so I'd like you to keep reading chapter 3. I'm not going to require that you read the whole thing, but I would like you to keep reading. So next week is when we'll finish it off. Okay, so I think you guys have been pretty good about working hard this week, and so as a reward, I'm not going to give you any homework tonight, except of course for the daily quiz, which I don't think really counts as homework. But there will be a quiz. Now I won't be able to post it for about an hour because it takes Zoom a little while to process the video here. Okay, so come back in an hour or two, and so the recorded video will be posted. There will be a daily quiz. It'll be short, and if you understand what we talked about today with significant figures and when to round, and when you multiply two numbers, how many sig figs you use to report your answer with. If you understood all of that, you'll find that today's quiz will be very easy. So I'm thinking we're done for the day. Before I end the recording, any questions from anybody? So nope, I'm not seeing any questions. Okay. All right, well, in that case, I'm going to go ahead and do the official countdown. So going once, going twice, sold.